Hi, today we're going to be going over B1 of Putnam 1988. This is widely regarded as the easiest problem on the easiest Putnam. The median score for this year's Putnam was 16 out of 120, which is much higher than the average median score of 0, 1, or 2. For this problem, out of the top 200 contenders, the average score was 9.56 out of 10. The problem also has an interesting generalization, and it displays a very useful trick in problem solving. If you want to give the problem a try, pause the video and do so now. Now that I hope you've given the problem a try, here's how to do it. First off, this is a number theory problem, it seems, about representing composite numbers greater than or equal to 4 in the form xy plus yz plus xz plus 1. How do we prove that a number can be of this form? Well, we can perhaps solve for x and y and z, or maybe something else. But a very helpful trick in problem solving is to try out some cases and to try to spot some patterns and maybe prove them. If it holds for a lot of numbers, chances are the pattern is true. Let's try out some cases then. Let's try to represent 4 in this form. Well, this one's an easy one. I can do it like this, which implies that 1, 1, 1 is a triplet. Let's try 6 now. I can do it in this way, and that implies that 2, 1, 1 is a triplet. As for 8, I can do it this way, so that implies 3, 1, 1 is a triplet. Let's try 9, the first odd number. This one's a bit tricky, but I think you can do it like this. 4, 2, 2 plus 1, and that gives us that 2, 2, 1 is a triplet. Let's try another odd number, 15. This one's also a bit harder to do, but I think 8 plus 2 plus 4 plus 1, which implies 4, 2, 1 is a triplet. Now what do we notice here? Well, for even numbers there are 2 values that are 1, whereas for odd numbers there's at least one value that's 1. In either case, it seems to be the case that at least one of the variables is 1. Let's just substitute that and see what happens. Without loss of generality, let's just substitute z equals 1. That would give us n equals xy plus y plus x plus 1. This does look like an expansion of some factorization, and if we do try to factor it, I can rewrite n as x plus 1, y plus 1. And the problem becomes trivial now, because we do know that n is ab, so we have ab equals x plus 1 times y plus 1. X equals a minus 1 and y equals b minus 1 would satisfy this equation, and hence we've shown that all composite numbers can be represented in this form. Another way to try it would have been by checking the factorization, the expansion of x plus z, sorry for the bad typing, checking the factorization of x plus z and times y plus z. Expanding this out, you get xy plus yz plus xz plus z squared, and this does equal our original expression here only when z is plus or minus 1. As we've been given that x, y, and z are all positive integers, z equals 1 would be the only solution. I hope you guys did enjoy the problem, but there's also an interesting general question to ask. We've shown that all composite numbers can be represented this way, but what about primes? Well, until now, we've proven that there's 19 primes that can't be represented in this form. The existence of the 20th prime is disproven on the assumption of the generalized Riemann hypothesis. So it still remains an open problem to know whether there exists a 20th prime that can't be represented in this form. That was one of the easiest Putnam problems ever. You can expect to not see a problem that easy for a few decades. That marks the end of the video. If you did enjoy the video, leave a like and comment what you liked the most. If you did not enjoy the video, also leave a comment letting me know how I can improve. I'm always open to hearing your suggestion. Please don't forget to subscribe and also hit the bell notification so that you can get notified whenever I post. I also have an Instagram page where I post notes regarding theory in mathematics. If that is interesting to you, please do consider following that as well. My @ is creative_math_.